A German engineer watched the footage on repeat for 10 minutes before he said a single word. What he'd just seen wasn't a movie effect. It was a 640-ton machine crawling across a half-finished bridge, suspended hundreds of feet above a valley, building the very road it was standing on as it moved forward. He'd spent 30 years designing bridge equipment. He'd never seen anything remotely like it. That reaction is becoming common. Engineers throughout Germany, Japan, and the United States keep stumbling across footage of Chinese construction machinery and reacting the exact same way, stunned silence followed by disbelief. A machine that digs tunnels using a metalworking secret pulled from a 2,500-year-old sword. A ship that vacuums sand off the ocean floor and fires it 9 miles through open air to manufacture entire islands within days. A crane capable of hoisting more weight than 3 Eiffel Towers combined. None of this is speculative or theoretical. These machines are operating right now, completing mega projects in mere days that once demanded years of labor. A 26-story skyscraper erected in 5 days. A 1,000-room hospital built in 10. A bridge so long and elevated that it slashed a 12-hour journey down to 3 hours. The machines accomplishing this are so massive, so fast, and so precise that the rest of the world is scrambling just to keep pace with what's already been built. If you're enjoying content like this, hit that like button, since these videos demand considerable effort to produce, and subscribe so you don't miss what comes next. But here's the actual surprise buried inside the story. It isn't purely the scale of these machines, it's how recently China lacked any of this technology whatsoever. Barely 17 years ago, they were importing every single piece of heavy construction equipment from other nations. Today, they're exporting machines nobody else on Earth can replicate. And that transformation starts with a single bridge-building beast that walks on 64 wheels. Builders throughout China simply call this machine the Iron Monster. It weighs 640 tons, stretches 299 feet long, and stands 29 feet tall. It's the largest land vehicle on Earth, and it accomplishes something no crane anywhere can replicate. It constructs a bridge by crawling across it while that bridge is still under construction. Consider how bridges normally get built. A crane sits stationary on the ground, hoists a bridge component, swings it into position, and workers bolt it down. Then the crane has to relocate, reset itself, and repeat that entire sequence. The Iron Monster discards that whole approach entirely. Here's how it operates instead. The front of the machine extends off the edge of whatever bridge section already exists. It reaches forward until contacting the next support pier, then anchors itself firmly there. While gripping that pier, an entire bridge segment slides forward and attaches directly to the machine. The Iron Monster then lifts that segment, which can span the complete distance between 2 piers, and lowers it precisely into position. Workers bolt everything down, and the machine crawls forward onto the freshly placed segment using its 64 fully rotating wheels. Then the whole cycle repeats. It essentially constructs its own roadway as it advances, and because it never needs to reach down toward the ground to retrieve anything, it moves remarkably fast. Unloaded, it travels at 5 miles per hour. Even under full load, it still maintains 3 miles per hour. That might not sound impressive initially, but for a machine this massive carrying bridge segments weighing hundreds of tons apiece, it's a remarkable performance. This machine built the Yibin Jinsha River Railway Bridge, a project connecting Sichuan and Guizhou provinces that cut travel time from 12 hours down to merely 3. It also worked on sections of the Belt and Road Initiative, a massive infrastructure undertaking often compared to rebuilding the entire ancient Silk Road. In regions where bridges needed to span deep valleys that no crane could possibly reach, the Iron Monster proved to be the only machine capable of finishing the job. That German engineer's reaction starts making a lot more sense once you understand what this machine was up against. But here's what makes this even more remarkable. China didn't always possess machinery like this. For decades, they relied entirely on equipment manufactured by other nations. The Iron Monster represents a symbol of something considerably larger, a transformation that unfolded within barely 2 decades. And the story behind how they pulled off something similar within tunneling proves even more astonishing. Before 2008, China didn't own a single tunnel boring machine. Every time they needed to dig beneath a mountain or under a river, they had to purchase or lease equipment from Germany, Japan, or the United States. That arrangement meant higher costs, smaller machines due to shipping constraints, and waiting on someone else's schedule entirely. So the Chinese government assembled an army of engineers with one clear mission: build the first domestically manufactured tunnel boring machine. In 2008, they succeeded. But that initial machine proved small and suited for only one specific type of terrain. The engineers weren't satisfied. They worked in continuous shifts, refining the designs repeatedly, and within a decade, Chinese tunnel boring machines were shattering records. In 2016, China built the world's first tunnel boring machine, powered by a permanent magnet motor system. In merely 8 years, Chinese engineers had progressed from copying other nations' machines to pioneering technology nobody else possessed. Then they started building machines making every other tunnel borer on Earth appear small by comparison. The largest among them is the Jianghai TBM. Its excavation diameter measures 54.5 feet. It stretches 475 feet long and weighs 5,000 tons. This machine is currently digging a tunnel beneath the Yangtze River to create the longest underwater highway anywhere in the world. It's equipped with a pressure-balanced cutter head that adjusts drilling intensity based on encountered rock conditions, a monitoring system tracking wear and deterioration in real time, and a dual slurry injection system keeping the cutting head clean and efficient throughout operation. But China isn't stopping there. They're constructing a new tunnel boring machine weighing a full 1,000 tons, twice the mass of the Jianghai. The problem with scaling a boring machine that large involves pressure. The bigger the machine grows, the more force surrounding rock and soil exert against it. Beyond a certain threshold, a conventional metal body would crack and collapse entirely under that strain. China found their solution in an unexpected place: the Sword of Goujian, an ancient weapon dating back to 496 BC that was discovered in remarkably preserved condition after remaining buried for over 2,000 years. The secret behind its extraordinary durability involved a blacksmithing technique where metal was heated then cooled using clay rather than water. Clay cools metal more slowly and evenly, producing material that's considerably tougher and less brittle. Chinese engineers replicated this exact technique to strengthen the metal used in their new tunnel boring machines, making them sturdy enough to scale up toward 1,000 tons without structural failure. China has also developed a rectangular tunnel boring machine, something nobody else had previously attempted. Circular tunnels waste available space because both the top and bottom curve inward. A rectangular tunnel uses available space considerably more efficiently and proves more structurally stable overall. These machines now operate worldwide constructing utility tunnels. The results speak for themselves. Today, 7 out of every 10 tunnel boring machines operating anywhere on the planet were manufactured in China. China exports these machines throughout the United States, the Middle East, and Western Europe. Within 17 years, they progressed from owning 0 tunnel boring machines to dominating the entire global market. But tunnels and bridges represent only part of this story. China has extended this style of engineering out onto open ocean too. There's a ship in China called the MV Tiankunhao, and its nickname reveals everything you need to understand: the island maker. This ship exists for one specific purpose. It vacuums sand off the ocean floor and blasts it through open air to construct new land where nothing previously existed except open water. Here's how it functions. The ship features a massive arm extending from its front, lowering down toward the seabed. At the arm's tip sits a dredger head, a rotating cutter digging into sand, silt, and mud along the ocean bottom. A powerful pump then sucks all that material upward through the arm and into the ship. From there, sand blasts out through a pipe, capable of being launched a distance exceeding 9 miles. Sand accumulates wherever it's aimed, and within days, an entirely new island emerges from the sea. This ship can excavate 6,000 cubic meters of material every single hour. Picture a cube of sand measuring roughly 18 meters on every side. That's the quantity the ship moves hourly, continuously. A few days of uninterrupted operation can generate a mound large enough to construct an airfield, a port, or an entire outpost built atop it. Other nations possess dredging vessels too, but the MV Tiankunhao operates on an entirely different tier. It excavates more material, throws it farther, and works considerably faster than anything else currently available. The ship itself measures roughly 460 feet long, and every inch remains packed with pump systems, dredging equipment, control rooms, and crew quarters. It's essentially a floating factory that doesn't manufacture goods. It manufactures land itself. China states the ship gets used for extending coastlines, repairing erosion damage, and supporting offshore construction projects. But experts also point out this ship grants China the capability to construct islands within disputed waters. Build an island somewhere in open ocean, then claim it as sovereign territory, and you've effectively extended your nation's maritime borders. With valuable resources like oil and gas being discovered along seabeds in regions where China maintains disputes with neighboring nations, the ability to manufacture islands represents a remarkably powerful strategic tool. Setting politics aside entirely, the engineering itself remains astonishing. Fitting a pump system powerful enough to move 6,000 cubic meters of sand hourly into a vessel merely 460 feet long demands remarkably precise design work. The entire system must function reliably under rough ocean conditions without mechanical failure. This represents years of accumulated research and testing, reflecting a level of marine engineering that few nations can realistically match. But as impressive as an island-building ship might be, China's largest lifting machines prove equally mind-bending. When discussing cranes specifically, China holds records nobody else has come remotely close to breaking. They've constructed cranes so enormous and powerful that comparing them against a standard construction crane resembles comparing a freight train against a bicycle. Start with the XGC 88000. This stands as the largest crawler crane found anywhere in the world. It reaches over 470 feet tall and weighs 5,350 tons. It holds the record for being the largest self-propelled ground vehicle by total size found anywhere on the entire planet. And it can lift loads reaching 4,000 tons, equivalent to hoisting roughly 2,500 automobiles simultaneously. Despite its enormous scale, it's engineered to be disassembled, transported, and reassembled at fresh construction sites. Then there's the Typhoon, a gantry crane that set the world record for the heaviest lift ever accomplished, hoisting a load weighing 20,133 tons. That record has never been surpassed since. The Typhoon was primarily built for shipbuilding purposes, allowing massive vessel sections to be assembled on the ground first, then lifted into position as one complete piece rather than being constructed slowly piece by piece across months. But even the Typhoon has since been outperformed. In 2014, China built the Jianghai crane, standing over 400 feet tall and rated to lift a maximum load of 22,000 tons. The crane itself weighs 11,000 tons, meaning that while carrying a full load, the total weight rolling along its rails reaches 33,000 tons, exceeding the combined weight of 3 Eiffel Towers moving along tracks simultaneously. For projects situated on or beneath water, China built the Jianghai 30, functioning simultaneously as both crane and ship. It can lift 12,000 tons within a single hoist, and using its auxiliary hoist system, that capacity climbs toward 13,600 tons. This crane vessel installed the underwater tunnel sections of the Hong Kong-Zhuhai-Macau Bridge, among the most complex sea-based projects ever attempted anywhere. Then there's the workhorse of the fleet, the XCMG XCA 4000. This particular wheeled crane drives directly to job sites under its own power, rather than requiring assembly from separate components. Despite that mobility, it reaches a maximum height approaching 560 feet and lifts up to 4,000 tons. China has been deploying this crane to install wind turbines nationwide as part of their broader push toward green energy infrastructure. It's precisely the right height for erecting a wind turbine's main column, and it can lift a 28-ton blade 530 feet into open air while holding it perfectly steady as workers attach it. These cranes aren't restricted purely to domestic use either. China has become a major exporter, shipping these machines toward countries needing lifting capacity no other manufacturer can realistically provide. But as remarkable as these cranes prove, they're merely machines that lift and relocate materials. The real revolution within Chinese construction might involve something entirely different, something reshaping how buildings themselves get constructed from the ground upward. China has taken a construction method most of the world still treats as experimental and transformed it into an everyday standard tool. It's called modular construction, and the results are almost difficult to believe. The underlying concept is straightforward. Rather than building everything on site, you manufacture entire building sections inside a factory instead. Walls, floors, ceilings, plumbing, wiring, all of it gets assembled indoors where weather conditions cannot slow progress down. Then you truck those completed sections toward the construction site and stack them together. It resembles building with giant Lego blocks, except each individual block arrives as a fully finished room, complete with windows, doors, and functioning plumbing. The speed involved proves genuinely shocking. One Chinese company constructed a 10-story apartment building within 28 hours and 45 minutes. Not 28 days, 28 hours total. That same company subsequently built a 26-story skyscraper in merely 5 days. A building taller than most city blocks worldwide, progressing from empty lot to standing structure in under a week. During a public health emergency, China deployed modular construction to build a 1,000-room hospital within 10 days. The building stood 2 stories tall with sufficient capacity to treat hundreds of patients simultaneously. That kind of speed can save lives during a crisis, and it's only achievable because those sections were manufactured inside factories beforehand and assembled on-site like puzzle pieces. The advantages extend beyond raw speed too. A modular construction site remains considerably quieter and cleaner compared with traditional sites. There's less dust, less noise, and less disruption affecting neighboring residents. And since most of the actual work happens indoors, rain and wind no longer cause construction delays. But modular construction represents only half of this speed revolution. The other half involves 3D printing, and China treats it not as some novelty, but as the actual foundation for how they'll build going forward. Enormous computer-controlled machines throughout China are depositing a mixture of cement and recycled construction waste layer by layer to construct complete structures. The robotic arms move with remarkable precision, placing each layer exactly where required. They're printing homes, bridges, monuments, and park structures alike. One Chinese company constructed 10 full-size houses within a single day using 3D printing technology. These weren't flimsy shells either. They featured solid foundations, windows, roofing, and insulation. China has also built the tallest 3D printed structure found anywhere in the world and printed every single building within an entire park. Now they're pursuing something even more ambitious, a 590-foot-tall dam that will be entirely 3D printed. If successful, it'll demonstrate this technology can handle some of the most demanding engineering projects on Earth. The cost savings prove enormous too. Once the design gets loaded into the machine, the only remaining human involvement is refilling raw materials periodically. A construction site that once required a dozen workers can now operate with one person, simply monitoring a screen. While 3D printing technology continues improving, China has already perfected another essential piece of the construction puzzle entirely: getting liquid concrete transported to the top of the world's tallest buildings. China holds the world record for the tallest concrete pump ever constructed. The Zoomlion boom pump reaches 330 feet into open air, meaning it can pump liquid concrete toward the top of most high-rise buildings effortlessly. For structures reaching even higher, China developed powerful line pumps that push concrete through tubing directly toward the target floor. Using this particular technology, Chinese companies pumped concrete to a height of 2,037 feet during construction of Building 117 in Tianjin, a world record that still stands unbroken today. Pushing liquid concrete upward 2,037 feet isn't simply a matter of switching on a pump. Concrete remains heavy and thick, And forcing it through such a tall tube requires enormous pressure alongside engineering capable of handling that stress without the pipe bursting or the concrete hardening prematurely before reaching the top. China solved these problems entirely and now deploys these pumps routinely across some of the tallest buildings found anywhere in the world. But all these machines, the pumps, the cranes, the tunnel borers, the bridge walkers, remain merely hardware. What's happening on top of all this equipment represents where the actual revolution continues unfolding. China is integrating artificial intelligence throughout its construction sites, and they're doing it right now. New models of excavators, cranes, and heavy machinery throughout China are being built featuring remote control systems connected directly to AI. These machines don't merely take orders from a human holding a remote control. They can operate entirely autonomously. An AI-controlled excavator can dig a foundation independently. An AI-controlled crane can lift and position materials on its own. An AI-controlled truck can haul away debris without human intervention. The complete cycle of a construction project can theoretically run without any human ever touching a single piece of equipment directly. This isn't merely a concept or prototype sitting somewhere on a drawing board. China is already deploying this technology across active projects. The Yangtze Dam is being constructed largely through AI and automated machinery. These machines receive instructions from a central computer system, navigate the site autonomously, and perform their assigned task with precision matching or exceeding what a human operator could realistically achieve. For tasks still requiring human dexterity, like laying bricks or smoothing plaster, China has been developing specialized robots instead. These robots can lay bricks in perfectly straight lines, plaster walls evenly, and smooth concrete floors with a level of consistency human workers genuinely struggle matching. These robots work faster, never grow tired, and don't make mistakes because they had a rough day. The overall result points toward a construction industry heading steadily toward full automation. No workers standing exposed in the rain. No injuries stemming from falling debris or equipment accidents. No delays because someone called in sick unexpectedly. One person operating a computer can now oversee work that once required an entire army of laborers. That particular vision raises real questions worth considering. Construction currently employs millions of people throughout China. If machines can perform this work faster, cheaper, and more safely, what happens to the people who previously held those jobs? It's a question extending well beyond China alone, because if this technology proves successful there, it will inevitably spread everywhere else too. Remember that German engineer staring silently at footage of the iron monster crawling across half-finished steel? He wasn't reacting to one impressive machine. He was watching the opening chapter of something considerably larger. A nation that decided 17 years ago it would never again wait on anyone else's schedule, anyone else's technology, anyone else's timeline. Every machine featured throughout this story, the bridge walker, the tunnel borers borrowing from ancient swords, the ship manufacturing islands from nothing, the cranes lifting 20,000 tons, the factories printing entire houses within a day, the pumps pushing concrete 2,000 feet skyward, and the AI now running the whole operation traces back to that same decision. Whether the rest of the world eventually catches up or simply purchases equipment from China remains a question that will shape how our entire planet gets constructed across coming decades. If you enjoyed this look at China's mega machines and want more content like this, hit the like button, subscribe, and turn on notifications so you never miss what comes next. So here's a question worth considering. If you could operate any single one of these machines for one day, which would you choose? And what would you build with it? Let me know in the comments.